Hello, my name is Evan Reynolds. I'm currently a postdoctoral research fellow on the NIH T32 Clinical Neuroscience Training Grant. I'm also a lead statistician here working with Dr. Brian Callahan and Dr. Eva Feldman. A little bit more about my background. I actually completed my PhD in biostatistics here at the University of Michigan in the School of Public Health. The focus of my dissertation during that time was on developing machine learning methods for use to make clinically relevant predictions. Machine learning has become a very popular class of methods used to make prediction using very complex data. There are lots of different machine learning algorithms that are put into place and used for research. Specifically in my dissertation, I focused on tree-based methods, which are one of the more interpretable class of machine learning methods. I found that those are very important in the clinical setting because we can't just have totally black box methods to understand prediction and associations, but rather implementing machine learning methods that we're able to see what's going on that gives some clinical validity to our results. Currently, I'm working on several research projects attempting to quantify the association between risk factors and complications of diabetes, specifically looking at components of the metabolic syndrome and how they are associated with neuropathy, nephropathy, and cognitive decline in several populations. And so biostatistics and statistics is really at the key center of all the research we do because statistics allows us to understand if the findings we have in our research data are those beyond random chance. So they allow us to find whether these are statistically significant findings, which allows us to determine what the results of our studies are. One recent study we've been working on is attempting to assess the longitudinal determinants of diabetic complications in the Pima Indians of Arizona. So this is a really interesting study for me because it involves a very important clinical research question, but also involves complex data that needed a somewhat complex statistical solution. And so what we were attempting to find in this cohort is whether longitudinal patterns of metabolic variables were associated with differential progression of neuropathy, autonomic neuropathy, and nephropathy in this population. And so these patients underwent yearly outcome and metabolic phenotyping. And so it's very complex data to understand how subtle changes in metabolic phenotypes are associated with changes in these complications of diabetes. And so what we did was attempted to look at how these trajectories of metabolic variables impact the changes in these outcomes during the follow-up. We actually presented this study at the American Diabetes Association scientific sessions a few weeks ago. And it's a really interesting paper that, for me, keys in on my love for applying complex statistical solutions with a very interesting and prominent research question. In our recent study of patients at the University of Michigan awaiting bariatric surgery, we measured how the metabolic syndrome components were associated with cognitive functioning using the NIH Toolbox Composite Score. And so far we've just looked at this at baseline, but we found that patients with a higher waist circumference were more likely to have lower cognitive scores after adjusting for many other factors, including age, sex, education, and writing ability. And so this is a really interesting study that we're following these patients over the next several months to see if these changes in weight may be associated with changes in cognitive decline. What we haven't dove into yet is a bit more complex data featuring these metabolic variables such as obesity. And so, for example, one thing I'm really interested in is taking a deeper dive from a data point of view at these variables. So rather than just looking at weight at the same time our outcomes are measured, but maybe looking at longitudinal or very long-term versions of weight and how we could understand how early changes in these metabolic variables might impact downstream complications. And so where my specialty is taking into account this very complex data that's difficult to, from the surface, understand what the associations are with these complications of diabetes, but using statistical methods to allow us to more clearly understand which important factors are associated with these downstream complications. Well, thank you for listening. I hope this has gotten you a little bit more excited about the power statistics and data science has in clinical research, and I hope you have a wonderful summer.